Algebra 2, Lesson 1. I'm going to do a little spin-off of a video that was done earlier, and I'm just going to focus on the steps that are given to you and offer you another idea, an alternative, if you will. So I'm going to basically do the same thing, except I'm going to not multiply both sides by the least common denominator and not cancel denominators. I'm going to do it a little bit differently. I'm kind of going to cancel the denominators, but it's going to look different than what was presented. So as an alternative approach to this question, if we have the three fractions given, the common denominator in this case, as mentioned in the previous video, is going to be 6k squared. Now what I'm going to do next is a little bit different. I'm going to get a common denominator like I had in previous units. And by doing so, I would look at each individual denominator and say, I have 6k, I need 6k squared, so I'm going to multiply top and bottom by k. I have again, I've mentioned this, if you have a subtraction problem, always take it to the numerator and put an addition problem in the middle instead, so a subtraction problem becomes adding a negative. The second fraction here has k squared, it needs a 6. The third fraction has 3k, it needs a 2k. So this is very similar to us getting common denominators with a rational expression. Now what happens is, if I take this and rewrite it, on the top I will now have k, that's this part here, plus a negative 6, that's this part, equals 10k. Now they are all over 6k squared now. That was the point of getting a common denominator. But what you have available now is that you can take all of this and take it away. So I could have not even written that part of the problem again, but I want to make sure it's clear that once you have a common denominator, you can ignore the denominator, and you're really just trying to solve this problem, which is something very familiar to us. Okay, so again, I want to go to another page and try another question in this manner. To the next set of questions, we focus on this one. The common denominator in this case, well, if I write this 1 as 1 over 1, the common denominator is x. So I'm going to take, so everything has what it needs except for the middle one. So I take top and bottom times x. Now at this point I will ignore the whole denominator and leave me with 5 plus x equals 1. And that's what I will solve. Again, this is merely an alternative to solving these rational equations than what was first offered. So the next one, we have denominators that need to be factored. So we would do so, and this one would have an a in common, which will leave us with a minus 6. The next one, again, take an a out, and we get a minus 6. So our common denominator is going to be a minus 6. So the first one has the a minus 6, but it needs an a. The second one has everything, and the next one has everything. So in other words, since all of the terms have a common denominator now, we can ignore them and now write a plus 6 equals 1 and just focus on this part. Again, merely an alternative. Now, the last one I'm going to try, and they're all similar if you found the pattern here, is this question right here. I'm going to put it over 1. And the common denominator is p squared. So the middle term needs p squared, so I multiply top and bottom by p squared, and we're left with, again, I can now ignore, once I have a common denominator, I can ignore all the denominators and just write the numerators down. And this becomes the problem that you will solve. Now, I didn't solve them, but that's something you can do. You have been able to do in the past, and I expect you to do it now, but I want to make sure that we could convert from a rational equation to an equation without fractions. Again, just a little bit alternative method to what was presented in the original video, and you're welcome to try it if you like.